Welcome to Mr. Rahman's Chemistry Corner. Today we are going to talk about matter. Our goals are to understand the differences between mixtures and pure substances. Also, we need to understand the concepts of elements and compounds. From the clinic that treats chemical dependency to a theoretical performance with good chemistry to the food label stating no chemicals added. Chemistry and chemicals seems an integral part of life, even if everyday references to them are often misleading. A label implying the absence of chemicals in food makes no sense. All foods consist entirely of chemicals, even if organically grown. In fact, all materials, objects, whether living or inanimate, are made up only of chemicals. And we should begin our study with that thought clearly in mind. Let's talk about the definition of matter. Matter is anything that takes up space and has mass. Matter is classified as pure substance or as a mixture of different substances. This is just a short and simple summary of matter. In this lesson and in the lessons going forward, we're going to talk about matters in terms of something that is pure, which we are going to call as substance, and then something that is not pure. In the other case, it would be known as mixtures. So just keep that in mind. Focus on one thing, and the other one should be exactly the opposite. Then we are going to talk about substances in terms of elements and compounds, and then we're going to talk about mixtures in terms of homogeneous and heterogeneous mixtures. Matter is made up of very tiny units called atoms. We're going to talk about atoms in a different unit. However, each different type of atom is the building block of a different chemical element. In this picture, we're going to focus on different colors. We're going to talk about matter as if like we're talking to a fifth grader. So if I ask you a question through the video, try to answer my questions as if like you're a fifth grader. So do not complicate your answers. For example, what do you see in the first box? So let's just say this is number 1. What do we see in that box? I see a bunch of red circles. Do I see anything different than red circles? My answer is no. So only thing I see in box number 1 is bunch of red circles, and they look identical. What do we see in box number 2? In box number 2, I also see red circles. They have similar shapes as well. But one thing that is different than box number 1 is in box number 2, I see the red circles as a pair. So that's the only difference between box number 1 and box number 2. But their colors are exactly the same, as you can see. What about box number 3? In box number 3, I see a red circle connected to a blue circle. And I did notice that they have 2 pairs. However, the pattern seems like the same. So it seems like there is a pattern of red and blue circle. What about box number 4? I do not see any pattern in box number 4. I see 2 blue circles, they're isolated from each other, and 2 red circles, they're also isolated from each other. They're not connected. Unlike box number 3, where blue and red circles are connected to each other, box number 4, every one of them seems separated from each other. There is no connection between each other. We're going to use that concept to talk about matter, to talk about elements, compounds, and mixture. As I said before, as we go forward, Do not complicate things for yourself. Keep your answers straightforward. Think as a fifth grader, and everything will make sense to you. So for example, if you look at this diagram, where we have mixtures, we have different things. We have a red circle right here. We have a blue and red circle together as a pair. Then we have a bunch of them that look similar. And then we have a solid blue circle. It's very easy to identify a mixture. Just keep it simple. What is mixture? You have different things mixed together. For example, in this example of mixture, I have one red circle, solid, one solid blue circle, a pair of red and blue circle. Actually, I have three pairs of red and blue circle. So that's a mixture of a solid red circle, a solid blue circle, and a pair of red and blue circle. There is no pattern, so we have a mixture of different things. For example, if you mix sand and salt together, that would be a mixture, because there is no mixture, right? There is no pattern. Another example would be, think about coffee with milk. If you go to a store and ask them for coffee with milk, the person might add a different amount of milk with your coffee. If you go to a different store and just say, can I have a coffee with milk? The person might add a different amount of coffee and milk compared to the first person. So that would be a mixture of a black coffee, I guess, with some added milk to it. So whenever you have different things together, that would be considered as a mixture. Mixture is something that is not pure. If I take this mixture and if I separate it, for example, if I separate those two red and blue circle, then that red circle by itself will be considered as an element by itself, right? That blue circle by itself will be considered as another type of element. If you take the pairs of red and blue circle, those pairs, even though they have different color, but since in that box they appear as the same exact, even though you see that there are two different colors, but still they're connected and they appear in the same exact box as the same exact pattern, and that should indicate a compound. What is a compound? A compound is made up based on a bunch of elements combined, chemically combined with each other. So in this case, I have a red and blue element chemically combined together to form that compound. If I even break that compound apart, so let's say I'm going to break this compound apart, this one apart, and this one apart as well, then obviously I'm going to get, in a box, I'm going to get red circles, and in a separate box, I will get blue circles. Those two are different type of elements. So going back to our previous slide, let's review this quickly. If you see only one type of circle, one color, one shape, that means, again, in this case, we're representing one type of circle with a specific color and specific shape as an atom, which we haven't learned too much about it yet. We're going to talk more about it in our next couple of units. But if you see one type of circle, we're going to call this one as an element. So number one is an element. Why? Because I do not see anything different in that box. All I see is same type of circles over and over again. So that's an element. If you look at the diagram for the number 2, here I see same colors, same shapes of elements, but then they appear as a pair as well. Since I don't see different color of circles, I'm also going to consider this as an element. Eventually, we're going to talk about different types of elements. So then you will understand what is the difference between the first one and the second one. For the third one, I noticed there is a blue and red circle, but they're connected with each other. When we draw things by connecting with each other in chemistry, we assume that there is a chemical bond in between them. And when you see different types of circle, different color circle are connected and drawn together, then that one would be considered as a compound. Finally, when you see different color or shapes that are not connected with each other, right? They're isolated. That's when you will realize that it should be a mixture. So be careful with compound and mixture. They might seem very similar to each other, but for a compound, things are connected. We draw the elements together. However, for the mixture, they're separated, right? So just keep that in mind before we go forward. So let's review this one more time. If we have different things mixed together, that's definitely a mixture. The name gives the idea away. Then if we have two or more different types of circle connected with each other and they have the same exact pattern over and over again, meaning in that box I see red and blue all over, and they're exactly the same, so then it would be a compound, meaning you have bunch of different elements chemically combined with each other. If you further separate them, then you will have only one specific type of circle with a specific pattern, and that would be considered as an element. You can see obviously this blue element right here is different than this blue element. This red element right here is different than this red element. So as we said before, that there is a difference between element number 1 and element number 2. So we see that same color circles appear twice, but in number 1 they are separated from each other, but in number 2 they appear as a pair. So what is the difference between number 1 and 2 diagram from this slide? Number 1 shows monoatomic element and number 2 shows diatomic element. Mono means 1, di means 2. So again, the name gives away the idea. So usually noble gases or some elements will exist as monoatomic elements, and there are very specific elements exist as diatomic elements in nature. There are 7 diatomic molecules or elements that exist in nature, and you should memorize the name of those 7 diatomic elements, meaning hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Anytime they exist in nature by themselves, you will always find them as a pair of atoms. So when we find hydrogen in nature, we're not going to find one atom of hydrogen, or let's just keep it simple, we're not going to find one circle of hydrogen. We're always going to find 2 of them connected with each other. Both of them are going to be same, maybe same shape, same size for now, but then again, in nature, whenever we find those 7 diatomic molecules, they always exist as a pair. So you need to memorize them from your reference table or periodic table. There are many tricks to memorize them. One of the trick is in your reference table, nitrogen, oxygen, fluorine, bromine, and iodine. There are 6 of them. 1, 2, 3, 4, 5, 6, 7 of them. Sorry, my fault. So there are 7 of them. Even though there are 7 of them, but there are 6 of them forms this almost 7 shape in your reference table. And one of them is up here. So you can think about 7-Up, soda that some of you might drink. So this is just one way to remember those 7 diatomic molecules. 6 of them forms a shape like 7, number 7, and one of them is up here, right? So it's just a trick that you might want to use to memorize those diatomic molecules. So we also need to remember this. Most of the diatomic molecules are gases, except bromine, Br2, which is liquid, and I2, which is solid. So just keep that in mind. The natural state of most of the diatomic molecules like hydrogen, nitrogen, oxygen, fluorine, chlorine, they are gases except bromine, which is liquid, and iodine, which is solid. Why iodine is solid or bromine is liquid while the rest of them are gases? We're going to cover this concept when we cover intermolecular forces. But at this point, it's too early. Whenever students think about chemistry, they always think about periodic table. I don't find any reason for you to memorize periodic table or elements from the periodic table because you're always going to have periodic table during your exam. But eventually, we're going to use the elements over and over again. So eventually, we are going to learn about all of the elements, or if not, most of the elements. So there is no point of memorizing it. I understand that some teachers would ask you to memorize it, but personally, I don't feel any need to memorize the periodic table, especially for Regents exam. The periodic table is given and all the names are listed in reference table and S. So why memorize if it's in front of your eyes, right? Chemistry is not about memorization. Now, let's talk about this. Compounds form when 2 or more elements are chemically combined with different proportions. So, common example of a compound is water. So anytime you go anywhere in the world and you wanted to have some water and you ask for it, someone will give you H2O, meaning there are 2 hydrogens attached with 1 oxygen. So if you go to a country, let's just say if you're in the United States and you ask for water, you're going to get H2O. If you go to UK and you ask for water, no one is going to give you H3O plus, right? It's still going to be H2O if you're asking for water and not something else. So why? Because water, H2O, it's a compound, and every time you have a compound, they are chemically combined with a fixed proportion. And that is the reason they are also considered as pure substance, meaning something will not change. So if I find water in the United States, forget about if it's mixed with something else. But if I find pure water in the United States, it should have 2 hydrogens and 1 oxygen in that molecule. If I go anywhere else in the world and I ask for water, it should have the same exact proportion between hydrogens and oxygen. So compounds are chemically combined with definite proportion, meaning their proportion will not change. So the question is, which diagram represents a compound and why? Look at the first diagram and then we'll look at diagram number 2. For the first diagram, I noticed that I have a red and blue circle. They're connected with each other. And it seems like I only have one pattern, meaning I have the pattern of a red circle connected to a blue circle. And that's a compound. Why? Because I have two different elements, a red and a blue element, a red and a blue circle, connected with each other. They're touching each other. And that connection represents a chemical bond between them. Diagram 2 is not a compound. Why? Because even though I see red and blue circles, there is no chemical connections between them. When we drew them, we did not connect the red with the blue one. And if they're not connected, that means there are no chemical bonds in between them. So what is diagram number 2 then? In diagram number 2, we have mixture of red and blue dots or circles. Again, by having dots or circles, we're representing elements at this point. So what do we have in number 2? We have mixture of different elements. What do we have in number 1? We have a compound with two different elements connected with each other, chemically connected with each other. So then the following question would be, can you break down elements into different substances? Can you break down compounds into different substances? Again, think about it as if like you are in 5th grade. Don't make things complicated. Think about this. Can I break this one down, the first one? So let's just say this is 1, this is 2, this is 3. If I break these red circles, I'm still going to have like red circles, pieces of red circles. Right? Maybe smaller pieces, but I'm still going to get pieces of red circles. Think about a chalk. If you break apart a chalk, you're still going to get powdered chalks. It's not going to be different. It's not going to be like pen or paper, right? So if you break something down and you still get the same exact thing, then it would be considered as an element. If you look at number 2, and if we break, even though there are 2 red circles, and if we break them down, what are we getting? We're still getting those tiny, tiny red circles, right? Nothing different. They're not going to be blue circles. So if we're getting the same exact thing, but maybe the sizes are going to be much smaller, then it is also going to be considered as an element. As I said before in my other slides, one of them is obviously monatomic element and the other one is diatomic element. But what about diagram number 3? If I break it apart, I'm going to get a blue circle and a separate red circle. And if that happens, then diagram number 3 represents a compound where 2 different elements are chemically combined with each other. So you can break apart a compound to get different elements, but you cannot break apart elements to get something different, at least for now, right? So I hope you enjoyed the lesson. Our goal was to distinguish between mixtures and pure substances, and our goal was also to identify elements and compounds, especially based on diagrams. In our next lesson, we're going to talk about mixtures and different type of mixtures. I hope you enjoyed the lesson, and we're going to talk more about matter in our next video lesson. Till then, please take care and be safe. Thank you.